So just to start out a little bit about myself, I've been sort of working as a Linux hobbyist for about 12 years. I started working as a systems administrator in 2006 when I got a job with a small tech services provider in Philadelphia. From there, I started working on a lot of open source projects. So over the years, I've been working on Debian, Ubuntu, and these days I work a lot on OpenStack. But for this talk, probably the most important thing is that I'm a member of the OpenStack Infrastructure Team. And we've open sourced pretty much our entire infrastructure except for secret things. So we have all of our configuration is online. This is our Git repository here, and I can bring it up. So this is running on cgit. This is our Git repository that has all of our Puppet configuration files and then all of the projects we use within the system that we run for OpenStack's infrastructure. So it's the infrastructure that all the developers use to develop on OpenStack. And a lot of people ask us how this all came about. So we were a pretty standard open source project where we had our infrastructure was sort of run by a few people who had keys to the castle, and they had root admin on all of our servers. So I brought some puppets of some of the initial people who were running the OpenStack infrastructure. We've got Jim Blair, who wrote Zool and a lot of our continuous integration stuff, and Monty Taylor. Oh, Monty needs his pink sunglasses. They're from a My Little Pony. Okay. So once upon a time, Monty and Jim were collecting bug reports. And they were thinking, you know, there must be a better way to do this. So Monty says, someone says, hey, I want a new feature in our infrastructure. Monty says, file a bug report. Uh-oh. And then he says, listen, Jim, we're an open source project. Can't we do this better? And Jim says, like have an open source infrastructure? And Monty says, yes. Then people in our team and in the wider OpenStack project can submit changes to our infrastructure directly, and we don't need them to submit bug reports anymore. And Jim says, yes, because we need to grow our team, and we want more people contributing. And Monty says, and we have to document it. So Jim says, yes, let's do it. So from then on, the OpenStack infrastructure was completely open source, and everything was put up into a Git repository for everyone to accept and submit changes to. Additionally, we also use our continuous integration system, which has code review using Garrett, automated runs with Jenkins. Thank you. To do all of our, everyone submits everything through code review, so the team of sysadmins looks it over. So of course, as an open source project, it makes a lot of sense for us to have an open source infrastructure. But inside a company, it can be pretty great too. So even if you don't open source it to the entire world, open sourcing it just to the people inside of your company has a lot of benefits. One that I found, first of all, is that I really love examples. I've downloaded Puppet modules in the past that weren't very good at documenting things. So I'd have a section of the Puppet config that would say something like, you know, SSH key goes here. And I'm like, well, is that a file? Is that a public key? Is that a private key? Is that the contents of the SSH key? And then there would just be like lots of things in the configuration that were like this. And so I didn't know which one they were, so I spent all week trying to figure out what variables go in what places. If you have an infrastructure like we do, and you have examples actually because you have your live configs out there, I don't have to spend time doing all of that because I know what belongs in those variables. Now, I wouldn't say we have the best practices when it comes to Puppet. Some of our stuff is kind of a mess. But it is actually consumable by other people for the most part. We don't really accept changes into our configuration if the code is really, really bad. And anyone can come and take our code. It's not like when I go to other projects and say, hey, you're running this really awesome service. I know you use Puppet. Can I see your configs? And they're like, no, they are not ready for public consumption. You can't use them. They're terrible. So for us, it made it so, we made it so that we have at least consumable architecture in our Puppet configs. And we sort of try to use better practices to make sure that other people can use them. We recently, it's sad that it was recent, but we upgraded to Puppet 3. And it wasn't too terrible. Over the course of the past few months, we've been trying to do like Puppet 3 happy code, updating our variables and making sure our latest commits were not just for Puppet 2.7. And as Puppet, Monty, and Jim said, it allows other people in your organization or in your company suggest changes to the infrastructure. That's been really important to us in OpenStack because developers are our customers. So developers actually know a thing or two about using computers, and so when they want a new feature in the infrastructure, we don't just have to tell them submit a bug. We can say, well, if you want this feature, we can probably get to it in a couple of months, or you can start writing a Puppet change or writing changes to our infrastructure. So it empowers people in your organization to pitch in with the work that you're doing. I'm also a big fan of open source, and I think sharing is nice. So a lot of people share individual Puppet modules, but I think having a fully open source infrastructure is a really interesting idea. So I will talk a bit about how we actually went about this. Our infrastructure has really changed over the years. We started out with something that we sort of just took from the private repository and just threw it out there on the internet. But we've in the past, I guess, year or so, we've started having downstreams, people who are actually consuming our code. It's not only people so we've got a team inside of HP that's consuming our infrastructure, people at Wikimedia, and then several other companies that drop by our channel sometime and say, hey, we're using all of your stuff, can you help us out? So we've become an upstream to all these projects, and we've been working towards making it easier for them to consume, which is what I'll talk about here. So the first thing for us, being an open source project, which has a lot of companies behind it, we made a decision early on that everything we use has to be open source. That's done, for one, because we don't want to offend anyone who's working on OpenStack, because inevitably we'd be using someone's technology over someone else's, and we'd be paying them for that. More importantly, we didn't want to be tied to a technology because that would halt development of the entire project for all the companies, hundreds of companies that are working on OpenStack. So if possible, I highly recommend using open source software. And if you can't use it everywhere, as most people can't use it everywhere, in your Puppet configs, I'd segregate out the proprietary stuff because the jury is still kind of out on whether all configuration files are open source. You can't just share configuration files from proprietary software. I don't think. It seems kind of unclear. I wouldn't do it. So segregate out your proprietary stuff from your open source stuff, because all the open source stuff you can open source more. This is one that really annoys me. Licenses. So Puppet modules and things that are published more formally, they tend to have licenses. But I find them on GitHub all the time, and a lot of them don't have licenses. People just put the code up there and leave it. And then I have to send them an email and say, what is your license on this code? And they're like, it's open source. I'm like, well, I need to know the actual license. And you have to say it to me in an email so I have a record of what your license is, otherwise I can't use it. And every single time I've emailed someone, they've said, oh yeah, it's open source, it's GPL, it's Apache, whatever. And I'm like, okay, that's fine, but don't make me email you. So I highly recommend putting licenses on things. And it's not something we're necessarily used to as systems administrators, so it takes some practice. You can either put a license header in every file, or you can just ship it with your code repository that the license is whatever the license is. But important, so I don't have to email you. So getting to actually doing the Puppet stuff to make this all work. The first step here is one of those ones that I would hope that people are doing already. And that would be using existing Puppet modules that exist in the world and writing your own Puppet modules with the intent of sharing. So not hard coding variables in there that are going to be different for other people. That's going to include things like file locations, like host names and addresses for things. So creating variables for all the custom data. And then keep those Puppet modules outside of the rest of your configuration. This is something we actually screwed up. So we have a ton of Puppet modules in our main config. And we're currently working on splitting all of those out because it made it really, really hard to consume really small portions of our infrastructure because you'd end up pulling the entire thing in. It also made it really hard to upgrade those modules that were inside there because we kind of forked them, and that was a bad idea. But you should already be doing this. We're definitely on our way to doing better at this. We're also working right now to split out our system configuration from our project configuration. So we've got all these servers that are running our infrastructure, but then we also have all these Jenkins definitions and these Zool definitions, which is sort of our merge master thing that makes sure all patches are tested against each other. But these all have specific jobs that are very specific to OpenStack. So we're running certain tests on different applications, and all of this is in like our massive configuration repository. And that's not so good, because if someone wants to run Jenkins and Zool and Garrett like we do, they don't necessarily want all the OpenStack jobs. So we're splitting out our system configuration from our project configuration, which will make it much easier for us to consume it. I think we're actually doing that on Thursday. So, so we're in the middle of doing this. I'd hoped it would be done by the time I did the talk, but it's not. But this is a huge step to making it easier to consume by other projects. We also split out all of our non-sensitive data from our configs, from the regular modules. So again, that's making sure you don't hard code things like web URLs and file locations and things. And then when we write our own modules, we make sure that we have variables for all those things so people can change them. We also found in our we shouldn't fork stuff and neither should you lesson is that we always try to contribute upstream. So if someone hard codes a file location and we don't want them to hard code a file location, instead of forking it and getting on with things, you want to work with upstream and see if they can get that added in as an option to change. And then it's easier to sync with upstream when you're ready to upgrade your modules. We also use Hiera, as many people do. It's pretty awesome, except for when it breaks. But it doesn't break all that often. We have a core team of people who have access to all the Hiera data. And it's particularly important for an open source project because you don't want all that stuff hanging around the internet. We have passwords, we have SSH keys and other things. And I can actually show you in our configuration. So if I go into our config directory, the kind of stuff we keep in Hiera. We actually learned the hard way that we have to keep email addresses in Hiera because when you have an open source infrastructure, people will just download it and run it, which is really funny for the first 5 minutes or so when their systems are sending us lots and lots of email, but then it's not funny. And it's very bad for them. So here's our massive list of things that we keep in Hiera, sorted by server. So our Garrett server, lots of SSH keys and passwords, GitHub authentication, because we mirror to there. And this pretty much shows all of our servers. And again, this is all on the open internet at git.openstack.org. So we use Hiera a lot. We're actually also working on splitting that off a bit, trying to make it easier, again, to consume by upstreams, because they sometimes have the same problem as I did with Puppet modules, not knowing exactly what goes into what, and how our hierarchy is set up. So another thing we did, we set up a Puppet board. Several years ago, we had a Puppet dashboard, but that became unmaintained. And once upon a time, our server filled up, and we said, we're not bringing that back because it's not maintained. So we brought up Puppet board a few months later. I can show you that. Where is it? So this is our Puppet board. We've turned off a few things. We've turned off querying because, again, this is on the open internet, puppetboard.openstack.org. Anyone can get to this, and that can be a little scary. So there's things that people can learn about our systems from this because it's all sitting out there. But the important thing for us is, since we have an open source infrastructure and we have people who are on our team who don't have shell access, like I don't have shell access to the servers, but I still submit changes to Puppet and I submit changes to our infrastructure. And I need to know what the servers are doing. So I submit a change, my colleagues review it, it gets merged into the repository, and then I say, did that work? So I could just go into IRC and say, Clark, did that thing work? Did that thing work? What broke? And he would look at the logs and get annoyed because he's busy. Or I could go to Puppet board and I can actually see what happened. So if I look here, let me just look at the cacti system here. I don't know if this is actually going to be any good. Well, you can see what it's been doing. I actually don't have a good example of one that failed or anything. But if I see one that failed, or if I'm waiting for it to apply, I see it come up. If it's failed, then I can go ahead and say, oh, it failed. I should go fix that in another review. And I don't need to bother anyone on IRC. I just figure out what went wrong. So that is Puppet board. And again, this is really useful even if you're not open sourcing things to the entire world and running Puppet board on the internet like we are. People in your organization can see that things have been applied or not and see what your servers are up to. Now this is one of the really, really important things about our infrastructure, is that we have kind of a ridiculous amount of documentation. We develop some software in our infrastructure. So I mentioned Zool earlier, which is sort of our merge master that makes sure everything's tested against each other. That's software that we wrote ourselves. We also wrote a tool called Jenkins Job Builder, which allows you to write Jenkins jobs in YAML format that then gets processed by the Jenkins server. It's much easier. And we found that developers can edit that file without causing too much trouble. When they were editing directly on Jenkins files, it was kind of a disaster and would break OpenStack. So we have a few projects that we maintain separately from just consuming systems administration projects. So we have documentation for all of those projects that we write, and then we have documentation for our entire infrastructure. And that is all found at ci.openstack.org. So we have sort of an introduction to how we do everything in our project, which is what I just described. And then we tell people how to do things like how they apply Puppet in our infrastructure. So we explain to them how this all works. And then we have steps that they can follow to actually grab our configuration, create a local.pp file that has the change that they want to they're trying to propose, and then how to install our Puppet modules and run the Puppet apply command to actually apply their local.pp to see if it actually worked. So this allows them to have sort of a micro environment of what we have on a specific server. So we give them examples on how to do all of that. We also do things like documenting sort of the bootstrapping and glue that we use. So when we add a new server, we tell people what they need to do. So in these instructions, you need to add something to the manifests. You need to add something to the site.pp and other things. And then it talks about what we actually do on our end. Right now, we still manually spin up some of the VMs. So if we're deploying a new web server for you, or we deployed a new Asterisk server recently. And the people who were running the Asterisk server had really nothing to do with our infrastructure. I think there were some people from Red Hat who were like, OpenStack needs an Asterisk server. And we're like, OK, you want to put it together? And they said, sure. So they followed these directions. We spun up the server and applied the Puppet stuff. So we try to give, and we also gave them SSH access, because we can give SSH access by server if someone is particularly interested in adminning something. So we had someone from Wikimedia for a while who was maintaining our wiki. Again, he's not really a full-time member of our team, but he comes and he makes sure our wiki is working all the time. So we have documentation for all of that. and all of the things like how we do backups, how we manage our Cinder volumes. We have this massive log server that I think has like 10 terabytes of space, and it's almost filled up again. So we have to manage our block storage, adding pieces to that. So we've documented that. And then for each one of our applications in our infrastructure, we have a page about how to use it. So let's see. So we've got Planet. That's a blog aggregation software. So the planet.openstack.org is managed by our team. We tell people exactly where the module lives. So if they're interested in, say, fixing up the CSS on our Planet, they don't need to learn about our entire infrastructure. We just have a link to our Puppet module, and then we have a link to like the site.pp, the planet.pp, which has some information in it, like where it gets stuff. So people don't really need to know about everything in our infrastructure. They can just go in on one thing that we're working on. And same thing for everything else, like our wiki. You know, we tell them where the module lives and where the PP file lives. So lots of documentation. We spend a lot of time doing documentation. We also document our contribution workflow. And since we're OpenStack, we use the contribution workflow that the rest of OpenStack uses. So we're using Garrett, so people submit code reviews to our project. That changes in configuration files, changes in Puppet files. And that's all documented on the OpenStack wiki, which is loading. There we go. This used to be a quick start, but I think it's actually longer than the non-quick start now. But we have very thorough documentation on how to actually send code into our project. And that's, of course, important because people want to know. It's a little scary, I know, right? And then for all of our Puppet stuff, we're using Jenkins to do a lot of tests on OpenStack stuff. And so we're like, well, why don't we run tests on sysadmin stuff too? So we run tests to do like Python script, syntax checking and other things. We run Puppet lint, Puppet parser validate against our Puppet files to make sure that, in theory, they should probably work fine. We haven't gotten a whole testing framework for making sure that the things actually apply very, very well, but we're sort of working on that. But we definitely document the workflow. In some teams, they don't have a big complicated thing like this, because the only reason we're using this is because this is what OpenStack uses. So you could just have a documentation that says, you know, issue a pull request against our GitHub repo, or submit a bug with a patch. But for us, this is what ours is, because ours is complicated. Yep, that's all of those things. And then, of course, there is the sharing of everything. So you can, of course, share specific modules on the Puppet Forge. You can toss them up on a GitHub repository. You can run your own Git server like we do and share them that way. But just get them out there somehow, either if you're putting them on the public internet and truly making it open source, or just putting it into your company and making sure everyone has access to it. And again, have a license so I don't have to email you and bug you about what the license is. So OpenStack is not the only one who does this sort of crazy open source infrastructure thing. I was actually kind of sad because there's another talk right now from the Jenkins guy who's running an open source infrastructure with Jenkins. I was talking to him in the speaker lounge. I was like, oh, you're doing the same talk. No. But Jenkins runs an open source infrastructure. It uses Puppet. So does Debian and Mozilla. Fedora used to, but I think they're switching off of Puppet. But a lot of these have lots of Puppet examples. And I found it was really useful for people who are getting into systems administration. If they want some real world experience, they can volunteer with an open source project like OpenStack or Debian, Mozilla, Jenkins. We all could use more volunteers. Also, a lot of these ones, they tend to hire people who have experience on their infrastructures. So it's fun to get familiar with some of these infrastructures for that too. And then I have a whole slide of resources. So again, I showed you the ci.openstack.org, all of our documentation. our repository on git.openstack.org. And then we have a couple of specs. I'll actually just open up these real quick. So in OpenStack, we have plans for the year, or for the 6-month cycle. And what we'll do is we'll submit a specification. So one of the things we wanted to do this cycle was split out our config, our system, and our actual configuration for projects. And then we also wanted to break out all the Puppet modules. So actually Spencer here wrote, I think you wrote both these specs? Just the bottom one? Yeah, so like first one is we're splitting out our config repo, which is the one that has all the config files and our system specifications. The cool thing about reading these specifications is even though they are really related to our OpenStack project, they go through some of the rationale of why we're splitting out these things. So this one, we'll have a problem description. So this is really fun to read if you have a similar problem in your organization. You can see how we're solving it, the rationale, how we're going to go about the change, and then the actual implementation and work items. So that's the one for splitting out those two sections. And then we have the one for actually moving our Puppet modules outside of our main config, which again talks about how we have this monolithic ecosystem and we don't want it to be so monolithic because we want people to be able to consume our architecture. So again, we have all these sections that go through and explain what we're doing, why, and then how we're going to tackle it. So it's really useful for us when we're planning these things, but it's going to be really useful historically too as we document fully in the open how we're solving the problems that we run into with our open source infrastructure and how people are consuming it. And these slides are going to be available online. So, oops, that was annoying. So, if you need anything. That was it. So, if you have questions?
So you said you try to reuse modules from the community, like other open source Puppet modules. Do you keep a local copy of those on cgit, or do you just pull them from GitHub whenever you need them?
So we pulled them. So the ones that we have in cgit. So actually, I'll open this up. So if you look under modules, we have a lot of modules. These are either ones we wrote or ones we forked. Bad us. So we're trying to split these all out. But then we also have ones that we pull directly from wherever they live. So I think it's the other one, yeah. Oh yeah, install modules, of course. So this will list all the modules that we're pulling. So these are actually pulled directly from where they live, the source. So.
Sorry. Can you go over a little bit of how you would split out private data in Hiera? Because we're running into a similar situation where you'll have common stuff in Hiera, but then you also need passwords, SSH keys, and you want to have that separate.
Right. So what we've done, I showed you, this is our modules directory and our massive thing. So we actually have an OpenStack project module, and that's where we put all of the custom stuff. So if you look under manifests, so say for cacti. So we've got a cacti module, and then we have our cacti.pp, and this is where we put all of the file locations and all of the stuff that's specific to us. Again, all of our servers that we define in cacti. So that's where we put all the public, non-sensitive data. So we don't actually put this in Hiera. I think we might at some point, but for now we just keep it in our own module. And then we reference, what do we do? So we pull in the module here and then apply it all. Yeah, that answers your question, I hope.
So I'm actually, since you mentioned Puppet again, the Mozilla, I'm actually talking about that tomorrow in the infrastructure software talk. So
awesome.
My question is about package repositories. Do you do anything sort of specific to handle mirroring upstream repositories, or just use upstream?
We don't. That's mostly because it's actually really hard. We run thousands of tests per day. So if our repo gets even slightly out of sync with upstream, it causes a lot of problems for us. So we have to have a repo that is immediately updated and doesn't get out of sync, or if it does get out of sync, we have to have a mechanism for doing that. Like if the server started downloading something and a package updated, maybe we just keep pointing them at that repository and wait until it finishes syncing. And so there's just a few syncing problems that we haven't quite solved with becoming a mirror. The way official mirrors do it for like Ubuntu and Red Hat or Fedora, they'll actually have like a more formal arrangement with the upstream. So for official Ubuntu mirrors, they get like a ping from Canonical that says, hey, we updated our mirror. But since we're not an official mirror and we're also not going to be a public mirror, it's a little bit harder for us. So we do have one guy working on the Fedora thing. I have sort of a half-finished module that tries to solve some of our problems up for review, but I think it's been in work in progress for like 8 months. So we're currently just depending on the mirrors that our cloud providers have for us. So we've got servers running on HP Cloud and servers running on Rackspace, and they run their own local mirrors, so that's what we use. It's not perfect. We've got a couple bug reports open for people saying, hey, the repository wasn't available, and we're like, sorry. It breaks sometimes. We do have a mirror for PyPy, or Pippy, is it how you say it? I don't know. The Python thing where you get stuff from. We do have a mirror of that. We used to actually use the software that they use, but now we use Bandersnatch to create just like a static listing of all the stuff. Because it turns out that goes down all the time. And so we have to have something for that. So we don't actually allow people to pull in Python stuff if it's not on that infrastructure. So.
Any other questions? Awesome. Well, thank you,
Cool.
Elizabeth.
Thank you.